How's it, grade 11th? So I'm still working from this chapter, Differentiation using Rules. I'm going to be doing the third example with you, which is this one over here. Okay, so what they've said to us here, they said this is example 3. So they've told us here, given that f of 3 equals -1, f dashed of 3 is equal to 6, and then we have g of 3 is equal to 4, and then we are given two other things, which is g dashed of 3 equals 2, and then f dashed of 4 equals 5. Then they say to us, determine fg dashed of 3. Okay, so what we have to do here is we have to use one of our rules, either the quotient rule, product rule, or chain rule. Okay, so what we've got here is we've got the product rule. All right, and what I'm going to do is I'm just going to go through a very simple example just to show you how we do that product rule again. So just over here, just as a little example, let's say that we've got x squared plus 4 multiplied by x cubed minus 7x plus 8, for example. Now, I know that this is going to be the product rule, or I can rather use the product rule because I have a function multiplied by another function. Okay, and essentially that is what we have over here. We have one function f multiplied by another function g. Okay, so how do we do the product rule again? Well, you differentiate the first one, leave the second, plus leave the first, differentiate the second. So if we had to differentiate this first one, we would get 2x plus 0. Okay, and then we leave this one here, which is x cubed minus 7x plus 8, plus we leave this one, x squared plus 4, multiplied by, sorry, I'm just writing on the next line, guys, and then the derivative of this one. So 3x squared minus 7. Okay, and that is what I'm going to do over here. But now, don't get confused that it's in functional notation, in other words, f and g. I'm going to be doing exactly the same thing here. So, just to show you, if this was f and this was g, what did we do? We took f dashed times g plus f times g dashed. Okay, and that is what I'm going to do with these function notations. So just want to highlight this. So we've got that one with that one, and then for the g we've got that and that. Okay, so here we go, function times a function, and don't worry about this 3 bit over here, that's just saying the function value of 3. Okay, so what we need to do is we need to differentiate the first one, so this will become f dashed, and it's of 3. Then we leave the second, so this is g of 3, plus leave the first, so this is going to be f of 3, and then we differentiate the second one, so g dashed of 3. Now, if we have a look here, we've got these function values. So f dashed of 3, they told us was 6. G of 3 is 4. Plus f of 3, they told us was -1. And then g dashed of 3, they told us is 2. Okay, so 6 times 4 is 24. That gives us -2 times the positive is -2, so we get a final answer of 22. So guys, I don't want you getting confused that they're giving it to us in functional notation. It's exactly the same method, okay, as you can see from there. So if we look at question B now, they're asking us f over g dashed of 3. Okay, so because we've got a function over a function, we have to use the quotient rule. Okay, and again, I'm just going to do a very simple example just to remind you guys how we do that quotient rule. So let's just say that we've got x squared plus 4 over x minus 7. Okay, so you remember with the quotient rule, we differentiate the top, multiplied with the bottom, minus, leave the top, differentiate the bottom, all over the bottom squared. Okay, so we differentiate the top, so that will give us 2x, leave the bottom, minus, leave the top, differentiate the bottom, all over the bottom squared. Okay, and I'm not too worried about simplifying it because I just wanted to show you the quotient rule. Okay, yes, you can simplify it, but that's not the point of this. So if we say that this is f and this is g, we took f dashed g, f g dashed g squared. Okay, so let's just color code these. So we've got our f, and then we've got our g, and then g squared. So that is exactly what I'm going to do here. Function divided by a function, quotient rule. So you differentiate the top, so f dashed of 3, leave the bottom, g of 3, minus, leave the top, differentiate the bottom. All over the bottom squared. So this is going to be g of 3 all squared. Okay, so we know what f dashed of 3 is. F dashed of 3 is 6. Multiplied by g of 3, we know is 4, minus f of 3 is minus 1. G dashed of 3 is 2. All over g of 3 is 4, and this is all squared. Okay, so we get 6 times 4, 24, plus 1 plus 2, all over 4 squared, 16. So we get here 26 over 16, and we can simplify that by dividing by 2, and we get 13 over 8. All right. Last example. Okay, question C. Sorry guys, I just need to turn my page up. So they're asking us here, f circle g dashed of 3. Okay, now this is from grade 10, your f circle g. Just remember, it means it's a function within a function. Okay, so I'm just going to do a very simple example here. So let's just say that we've got x squared plus 7x plus 9 to the power of 3 over 4. Okay, now if you remember from my previous video, we've got an inside function and then we have this outside function. Okay, and when we have that situation, we need to use the chain rule, okay, where we differentiate the outside, then we differentiate the inside, okay? So if we had to differentiate this, multiply the 3 over 4 with the coefficient in the front, and we get 3 over 4. Leave the inside. Then decrease that power by 1. And we get minus a quarter. So that's the derivative of the outside. I haven't even touched the inside function yet. What we need to do now is we need to differentiate that inside. So that will give us 2x plus 7. Okay. Yes, grade 11s, I can simplify it and take it further, but that is not what I'm interested in. I just wanted to show you how the chain rule works, okay? So let's just summarize here. So that's the derivative of the outside function, and then this is the derivative of the inside function, okay? So basically, this is our g, the inside function, and our f is the outside function. So what did we do here? F dashed, and then g dashed. And inside here we have the g. So f, and then we have our g, and then g dashed. Okay, so that is what I'm going to do over here. So we need to differentiate the outside function first. And so basically, I'm going to rewrite this in a different way, just to show you guys. So we've got f of g of x, okay? Don't worry about the 3 just yet. I'll put the 3 in a second. I just want to differentiate this as it is like this. So we differentiate the outside. So we get f dashed, which is that, and we leave the g. So g of x. Then, so that's that bit. And then what did we have to do? Differentiate the inside. So we get times by g dashed of x. Okay. So what we've done is we've used the chain rule to differentiate f circle g. Now we're interested in with the function value of 3. So f dashed g of 3 times g dashed of 3. Okay. Now, if you remember g of 3, if I just go back here, g of 3, they told us was 4. So a g of 3 here is going to be 4. So we get f dashed of 4, because that g of 3 is 4 times, okay guys, just to save from me turning back, I'm just going to have a look at the question in the book here. They told us that g dashed of 3 is 2. All right, then f dashed of 4 is 5. So we get here 5 times 2, and that gives us a final answer of 10. Okay, so guys, don't get confused that they are giving you functional notation. Method is exactly the same. All right, so for homework, what I would like you guys to do is you can finish off question 3, 4, 5, 6, 7, and 8 for me, please. Thank you.